Well, hello, third graders, and welcome to today's lesson, number 19 in our math journals, in our math program, number 19 in the third module. What do you see? If you're seeing what I'm seeing, we're seeing pennies in the ones place. Well, that's where they belong, actually, right? They represent ones. How many rows do you see? I see 2 rows. 1, 2. What's the size of each row? 3. So what would be the related multiplication sentence? We would say 2 rows of 3 is equal to 6. Of course, we could also say 2 groups of 3 equals 6. Or we could say 2 times 3 equals 6. Or for that matter, since we're on a roll, we could say 2 threes, right? Because that's a 3, and that's a 3. 2 threes. So, what would happen if the same array, if this same array were here? Well, we couldn't just put pennies here because pennies are ones. What would we have to put here to show tens? Well, if you're thinking what I'm thinking, we'd have to show tens, right? We'd have to show tens. So here, we have the same array. The array is exactly the same, right? We have 2 groups of 3, 2 rows of 3. Except we don't have rows of 1s now. We have rows of 10s. So here we have 2 rows of 3 10s, right? 2 rows of 3 10s, we would say it like this: 2 rows of 3 10s, and the 3 10s ever have the value of 30, right? 10, 20, 30. That row has a value of 30. So here we have 2 times what looks like 2 times 30. 2 groups of 30. And the answer is 60, which is the same value as 6 10s, right? Now, this is nice and slow as we look at this, but the idea is huge when we think about other arrays that could be either thinking of them as ones or as tens. Okay, let's take a look at an example. And this example appears in your journal on page 115. And here it says use discs to fill in the blanks. Well, look what we have here. Inside each disc is labeled as a 1, right? So let's see if this makes sense for groups of 3 1s. Just to be sure, this is kind of like what we just did. That's a group of 3 1s. So 4 times 3 1s altogether is equal to 12 1s, right? And 4 times 3 is equal to 12. Hey, that makes sense. We've been doing this for many, many weeks, right? But when we look here, the array is the same, but the value of each thing inside the array is not. It's 10 times bigger, right? We're working with 10s. So what would that mean in terms of the number sentences? Here we have 4 groups of 3 10s, right? Because each one of these rows is 3 10s. So how many 10s would that be altogether? Well, it would be 12 10s. 3, 6, 9, 12. 12 10s. And what is the value of 12 10s? Well, the value of 12 10s is 120. Now, around this time, some second graders start noticing something. And the second graders start noticing, hey, this is interesting. The basic fact here, 4 times 3 is 12. And the basic fact, 4 times 3 is 12. You can see it in this sentence, right? Except the answer is 10 times bigger, and that's why the 0 is there at the end. Because anything that's 10 times bigger is represented with a 0 at the end of the basic fact. So this is an interesting observation. And if you make the observation and it makes sense to you, then this lesson is just going to make total sense, and your math thinking advances really nicely. That we can start multiplying by tens fairly quickly, fairly efficiently. What we have here? Ones. How many ones? 2 groups of 4 ones. Well, what is 2 groups of 4? 2 groups of 4 is 8. 8 ones. 2 times 4 is 8. What happens when that array is in the tens place? Well, we have 2 groups of 4 tens, right? There's 4 tens, right? So 2 groups of 4 tens equals how many tens altogether? Well, we have 8 tens. And 2 groups of 4 tens can be said in a different way. It can be said as 2 times 40. And what is 2 times 40? 2 times 40 is the same value as 8 tens, which is 80. Again, those of you looking for interesting patterns see that the basic fact 2 times 4 equals 8 is present. It's there. Even if it's blurred sometimes, it's there. But the answer is 10 times bigger, and that's how we end up with this 0 on the end. Some kids sometimes say, oh, that's easy, you just add a 0. That's confusing, because we're really not adding a 0. We're just showing that the product, the answer we get when we multiply, is 10 times greater. And the 0 shows that. Okay? So, I want to look at another problem here with this. This happens to be on 117. It's part of the exit ticket. I think you should do it with me. Just flip there and do it with me, okay? A small plane has 20 rows of seats. Each row has 4 seats. Well, thankfully, they did a little drawing. And there we have 1, 2, 3, 4. Yep, sure enough, 4 seats in each row, right? Find the total number of seats on the plane. Now, I know that, some kids could just say, well, I'm going to find that out right now. 1, 2, 3, 4, 5, 6, 7, 8, 5, 10, 11, 12. And of course, that's possible. But it sure isn't efficient. We've learned how to use multiplication for a reason. And it's to make our lives easier. Right? So what do we have here? We have 20 rows of 4, right? We have 20 groups of 4. We have 20 times 4. Yeah. And if we can think of it also as 4 20s, either way, if that makes it easier for us, we know the answer is going to be the same. And the basic fact here, the fact that we know, is that 4 2s or 2 4s is 8. Right? That's the basic fact, is 8. But that the 20 is 10 times bigger than 2. So our answer is going to be 10 times bigger than 8, right? Yeah. And that's the cool thing about this pattern, and recognizing that when we're working with tens, that we still have the basic fact, except our answer is 10 times greater. How many seats would there be on 3 planes? Oh, well, this is how many seats there are, right? 80 seats on each plane. So here we would need 3 groups, or 3 planes, right? 3 groups of 80, right? Because there's 80 seats on each plane. So once again, we end up thinking about this. We can think about this as 3 groups of 8 tens, right? 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. These are tens. 1, 2, 3, 4, 5, 6, 7, 8. These are all tens. Well, if they were ones, 3 times 8 would be, let's count by 8. 8, 16, 24. Sure enough. Well, yeah, there's 24 right there. 24. 24 tens. What's the value of 24 tens? Well, the value of 24 tens is 240. So, 240 seats on 3 planes. That's pretty cool, isn't it? Can you imagine the power of using this rule for the rest of your life? Multiplying by groups of 10? Pretty powerful. I would love to see your work on the page before this, page 116. Okay? And if you want to get warmed up on 115 and finish up what we didn't do, that would be awesome. And then, like I said, I'd like a picture of your work on, not the upside down one, but the regular sized one. Okay? Best wishes. So long.